All right, let's put on our digital detective hats. When there's a cyber incident, you can't just dust for fingerprints. The entire crime scene is invisible. It's just data. So to crack the case, investigators need a map, a reliable roadmap to follow the evidence. Today, we're going to unfold that map.
And that really is the million-dollar question, isn't it? How in the world do you solve a crime you can't physically see? The scene is nothing but network traffic, billions of bits zipping back and forth. It's this chaotic, invisible storm. But hiding in all that chaos is a story. The story of exactly what happened, who did it, and how they pulled it off.
And that's where network forensics comes into play. It's the science of methodically digging through all that network traffic to find the digital breadcrumbs and piece that story together. This isn't about guesswork. It's a careful process of collecting and preserving digital evidence so that it can actually stand up in a court of law. Now, our roadmap for this whole investigation is a framework you might have heard of called the OSI model. The easiest way to think about it is like a 7-story building. Every single piece of data has to travel up and down these 7 layers to get from you to a server and back again. For a forensic analyst, each floor of this building holds a different kind of clue. We're going to start at the very top, layer 7, and work our way all the way down to the physical wires. So our investigation kicks off right where the action starts, with the user. These top layers, 7 down to 5, they tell us what the user, or, the attacker, was actually trying to do. At the very top, you've got layer 7, the application layer. This is the most human part of the whole model. This is where we see the actual content, the juicy stuff. An investigator can literally reconstruct files to see if malware was downloaded, they can read the text of a phishing email, or even find usernames and passwords if they were sent in clear text. And using a tool like Wireshark, an analyst can get laser-focused. A simple filter, just like this one, can instantly pinpoint any computer on the network that tried to contact a known malicious website. It's basically the digital equivalent of finding a suspect's phone records showing a call to a known accomplice. It's that direct. So, the most important thing to remember here is this. Layer 7 evidence tells you the why. It reveals the intent. It's not just random data flying around. It's a person trying to open a file, or it's a malicious program trying to phone home to its command and control server. Layers 6 and 5 are kind of like the middle managers. The presentation layer, layer 6, it handles all the formatting and encryption. Was the conversation scrambled with strong encryption, or was it wide open? And then the session layer, layer 5, is like a secretary. It sets up the conversation, keeps it going, and then tears it down when it's over. Evidence here can show how long a connection lasted, which can be super important. Okay, so we know the user's intent. Now we have to follow the data itself as it starts its big journey across the internet. And this brings us down to the logistics department, layers 4 and 3. Layer 4, the transport layer, is all about addressing and making sure the data gets there reliably. Now look at those port numbers. If an IP address is like the street address for a big apartment building, the port number is the actual apartment number. So port 443 means the data was going to the secure web apartment. Port 22 means it was headed for the remote admin apartment. This tells an investigator exactly which service was being used. And that is the key takeaway for this layer. By looking at the port numbers in Layer 4, investigators don't just see 2 computers talking, they can see that a specific web browser was talking to a specific web server, or that an attacker was trying to brute force a specific database service. It's incredibly specific. And now we get to Layer 3, the network layer. And this is where we find one of the most critical pieces of evidence in pretty much any investigation, the IP address. This is the global, routable address of a device out there on the internet. Finding the source IP is usually the first huge step in tracing an attack all the way back to its origin.
An IP address just looks like this, a series of numbers, but it uniquely identifies a device on the internet, just like the mailing address for your house. Now, sure, these can be faked or hidden behind proxies, but more often than not, it's the single best clue for figuring out where on planet Earth an attack actually came from.
So we've traced the attack from the vast internet right up to our network's front door, but now we have to find the exact device inside the building. For that, we need to zoom in from the global internet to the local network, and that is the job of layers 2 and 1. At layer 2, we find a totally different kind of address, the MAC address. Now, this isn't a mailing address. It's more like a unique serial number or a fingerprint that's literally burned into the physical network card of a computer or a phone or a server.
This is the golden ticket. It's the evidence that lets an investigator say, it wasn't just some computer on our network, it was that specific laptop. So what's the difference between an IP and a MAC address? Oh, it's absolutely crucial. Your IP address changes depending on which coffee shop's Wi-Fi you're using. It's temporary. But your device's MAC address is permanent. It's fixed to the hardware. On a local network, the MAC address is the definitive, undeniable link to a single piece of equipment.
And finally, we arrive at layer 1, the physical layer. You notice something different here? No Wireshark filters? That's because this is where digital forensics stops, and good old-fashioned physical detective work has to take over. We are talking about the actual cables, the ports, the hardware itself.
At this last layer, the investigator has to get their hands dirty. They're physically inspecting cables for wiretaps. They're looking for unauthorized little devices plugged into network ports. They're digging through switch logs to see which physical port a suspect's MAC address was connected to. This is how you prove, without a doubt, that the attack came from the laptop plugged into the third desk in the accounting department.
So after that long journey down all 7 layers, the investigator doesn't just have a random pile of clues. They have a complete, coherent story.
And this is how it all just snaps together. Layer 7 revealed their goal. Maybe to steal files. Layer 4 showed they targeted the file server specifically. Layer 3 gave up the attacker's source IP address. Layer 2 identified the exact compromised workstation by its MAC address. And finally, Layer 1, through switch logs, showed it was plugged into the port at an empty cubicle. See? Each layer answers a critical question, building the case from the top all the way to the bottom. It's just a really powerful way to turn those invisible streams of data into a concrete story of exactly what happened. Which leaves us with just one final question for you to chew on. If every one of these layers is constantly telling a story on your network, what exactly is it saying right now?